Hi everyone, my name is Xudong and work on the Bazel team at Google, mostly on external dependencies. This is that talk, managing external dependencies with Bzlmod. So first up, a word. This is you can see this is from the same slides that I'm using for the Google Open Source Live event. There's a Bazel Day on March 1st. But the thing about that one is that one is recorded, so you get the version with live questions and fuck-ups. I didn't say that word. Okay, so first up, let's talk about the basic concepts surrounding external dependency management in Bazel. So starting with what is an external dependency. So imagine you have your Bazel workspace, which is with all the source directories and the files you would normally have. This is the directory you're running your Bazel commands from. An external dependency is basically anything that's not from this directory, so also called your workspace. So with Bazel, these can come in multiple forms. They can be rule sets. So Bazel only ships with support for some languages, like C++ and Java. But you can pull in rule sets authored by the Bazel team and the community to build code in other languages, such as rules Go for Go and aspect rules.js for JavaScript. These rule sets are often available on GitHub under the Bazel build org, or in the case of aspect build. Another common form of external dependencies is integration with other package managers from other languages or other systems. So if you're coming from an ecosystem where there's already a popular package manager, Bazel allows you to integrate them into your build. This includes things like Maven, NPM, the Go modules, or what have you. And also, an external dependency doesn't necessarily come from the internet. It can be, certain builds can make use of toolchains installed on your local machine. For example, C++ builds in particular. So configuration of such toolchains often happen before the build actually runs. So we try to look up what, for example, what GCC or what Clang you have installed on your system. You might be familiar with such steps called like configure before you run your GNU make thing. So you often do like /configure and make. But in Bazel, it's all just one command. So this form of external dependencies can also be taken care of by Bazel. To reiterate, anything included in your build outside of your project directory is an external dependency. And Bazel is extensible enough to support many different kinds of them. So what Bazel offers is all that is abstracted away with the right configuration. So just run Bazel build, and all the downloads and like toolchain discovery and whatnot will happen in the background on demand. Okay, so how does Bazel do all this? Bazel models each external dependency as a repository, or repo for short. So each repo is a magic directory that can be materialized somewhere on disk according to some instructions. So this materialization happens on demand. So whenever you need something from this external package or whatever, that's when it's fetched. So this materialization also is referred to fetching the repo. Following our previous examples, we could define a repo known as rules Go to be fetched by downloading a zip. I didn't put the URL here, but imagine it's github.com/Bazel build, blah, blah, blah.
Only stable releases.
Oh, yes, it's a good thing. It's a feature, not a bug. Except it's a bug on GitHub site. So actually, GitHub just posted a blog post, I think yesterday, saying, we promise not to do this again, officially this time. So what Itai is referring to is download the zip archive from URL 1 and make sure it has the right checksum before extracting it. But the checksum changed at the end of January, and it's because GitHub updated their compression algorithm. which they had promised to us before that they wouldn't, kind of informally. But now there's a formal guarantee that they're not going to change it within like the next year. And even after, if they change it, they're going to like give you plenty of notice. But the thing is, just use a different, don't use the source archive downloads. You can upload your own release archives. And those you can have whatever checksums you like, whatever compression algorithms you like. So yeah. Okay, that's a detour. Where were we? Yeah, we could define a repo known as rules.go to be fetched by downloading a zip archive from a certain URL and extracting it. Similar for rules.js. We could define a repo known as Maven, which is fetched by downloading a certain list of artifacts from Maven Central. Or similarly for NPM, we can talk to NPM. Or we could define a repo known as local cc_config to be fetched by essentially running a shell script that first discovers the locally installed tool chains and then writes the information into a repository so that later steps of the build can use it. As you can see, the instructions to fetch a repo can basically be anything. It can be downloading something, can be talking to a package manager, it can be just an arbitrary shell script. So this affords a lot of extensibility for your build. Note how the names of each repo is prefixed with an @sign. This is the primary way for us to address and use them. So we can see some examples. This is a very basic build file that declares a very simple CC binary target building a C++ executable. If you're not familiar with Bazel, if you were just at the boot camp, these things are called labels. You should have been notified about them. Nice, good, thanks. So these labels, they're starting with // they refer to other targets, if you didn't pay attention during the, so labels beginning with double slashes, they refer to other targets within the same repo. So in this case, the same repo as your build file, basically. So in this case, this is the main repo, which is your Bazel workspace, so where you write your source code. So instead of using a copy of the zlib thing, as we write here, if you write it like this, you need to have a directory called zlib_src, and in there you probably have a copy of the source code of zlib. Instead of that, we could define a repo called a zlib, and then just tell Bazel that it needs to be fetched from GitHub, or zlib is actually from zlib.org or something. And then use it like this in your build files. So this is the way, like @zlib is for you to refer to targets from another repo. We'll talk about how to define repos later. So in addition to using targets from other repos, you can also build rules from other repos. This is an example of using the Go binary from rules.go to build a Go executable. Okay, so apparent versus canonical names. One important concept you should understand about repositories is the distinction between its apparent name and canonical names. In our previous example, we saw how we could use the repos from our project sources by using a single @sign. Those names, such as rules.go, Maven, are the apparent names of the repos as viewed from the main repo. Bazel knows how to translate those apparent names into each repo's canonical name, which is slightly mangled, like with the tilde and stuff, and unambiguous. So each repo has one canonical name in a workspace. So canonical repo names can also be directly used. Like you can just, when you write the label, you can write a double @ and then that kind of mangled string and then / whatever target. But such usage is brittle because when you upgrade a version, this might change. And you're not supposed to use canonical repo names directly, basically. So from the perspective of another repo, the apparent names might be different. For example, this is from the perspective of the aspect rules.js repo. So it sees itself as this name. It sees like the npm thing, which we saw as this is from the perspective of the main repo, as in our workspace. So we call this as npm. It calls this as generated npm, and furthermore, it doesn't see some repos at all. Like it doesn't see rules.go. So this is, as it has no apparent name for it. This is some sort of visibility restriction. Okay, so if we think of repos as people and cats, this distinction may be easier to understand. So imagine these two are neighbors, Fujiko Watanabe and Michael Edwin Petrucci. These are their official canonical names on their passport, but nobody calls them by these names. Instead, Fujiko calls Michael-san, and Michael calls Fujiko, Fujiko. So yeah, the blue ones are apparent names, and gray ones are apparent names. Oh, sorry, canonical names. And a single repo might have different apparent names in the context of different repos. So like the neighborhood cat, so the neighborhood cat's apparent name is Azuki-chan to Fujiko, but butterscotch muffin to Michael. So different repos can refer to the same repo, but like each have their own, like what they think their name is. Also, not every repo knows every other repo. The cat, of course, considers itself above knowing the names of those puny humans, so it has no apparent names for them. All right, so enough of those silly shenanigans. Let's get to the meat of how we define repos. The main concepts we'll talk about here are modules and module extensions. So first off, a quick callback to the name of the talk, managing external dependencies with Bzlmod. So what is Bzlmod? It is the code name of a new external dependency management system in Bazel. Generally available since Bazel 6.0, released in December 2020. It's not enabled by default yet, so you'll need to use the -- enable Bzlmod flag with your Bazel commands. There's an older system based on the workspace file, which is, if you're a Bazel veteran, you're probably aware of how it roughly works and how much it sucks. But we're not going to talk about that here. We're only about the future. So the core concept of Bzlmod, as the name suggests, is the Bazel module. A Bazel module is just a Bazel project that publishes its metadata, such as its name, version, dependencies. So this should be a familiar concept coming from most other package management systems. To define your module, you just need to create a module.bazel file at your workspace root. So here we just give it a name and a version. To specify direct dependencies, we use the Bazel dep directive to specify a name and a version. So we can ask for rules go at this version, aspect rules.js at this version. Where do these names come from? It's from the Bazel Central Registry. So this is the main home for Bazel modules and the registry used by Bazel by default. It hosts module metadata, but instead of also hosting the source archives, it just stores URLs pointing to them. It's served from bcr.bazel.build and has a nice web front end contributed by our community at registry.bazel.build. Where you can browse the list of modules and versions available. It's very much a work in progress. There's still some kind of key modules missing, so contributions welcome.
There's like a protocol quality for me if I want to have my own registry?
Yes, we'll talk about that in a bit. So back to our module.bazel file. Yeah, so each Bazel dep eventually turns into a repo. Of the form, download an archive from somewhere and extract it, because the registry tells you, this version of this module is stored at this URL, basically. Yeah, so the URL comes from the registry, and the apparent name of the repo defaults to the module name. So here we will just say rules go, this dep gets turned into a repo whose apparent name is rules go. And you can also customize it by using the repo name attribute. Like for aspect rules.js here, we'll just call it rules.js. You can bring in any Bazel module as a dependency this way, be it rule sets or other helper libraries. Someone's not happy about that. Anyway. Yeah, good. I didn't know we had like a 3-year-old attending this. Anyway. Yeah, okay, transitive dependencies. So one notable thing about declared dependencies this way is that you only need to declare direct dependencies. This is new from people who came from the workspace world. So transitive dependencies will be handled by Bazel automatically. So this might seem obvious, but it was not always the case.
What about the diamond?
What about the diamond? Yeah, how did you know I was going to talk about this? So, in case of a version conflict, also known as the diamond dependency problem, we just use the minimal version selection algorithm employed by Go modules. If anyone here works with Go, you should know that's how the Go module system works. In which case, we just assume backwards compatibility and pick the highest version that's currently that's in the dependency graph. So in this case, rules Go and aspect rules.js both want a version of Bazel Skylib, but aspect rules.js wanted the higher one, so we picked the higher one. This approach has several pros and cons. There's too many of them to discuss here, but basically know that we deliberated and we decided this is good enough. It works well for most cases, and it's very simple. It's a very simple concept. Just pick the highest version that you asked for. So notably, this does not go to the registry and ask, oh, what's the latest version of Bazel Skylib?
Who ensures that if rules scope was only tested with Skylib 130, that it also works with 140?
So the question is, who ensures that rules Go also works with 1.4.0 of Bazel Skylib, given that it only asks for 1.3.0. So we do assume backwards compatibility. If you are not backwards compatible, you should up your kind of major version number. And we have a field called compatibility level in the module metadata to say, okay, so the Bazel ecosystem is a bit varied. Not everyone uses Semver. So we can't just assume the first number is the major version number. So we allow you to have an extra field that says, this is my major version, basically. So if you have both 1.3.0 and 2.4.0, we would just say error. We can't deal with this.
There's no way. If I have 1.3 and 2.1?
There are ways to work around it. There's ways to, if you were the root module, you can specify overrides, I decree this fine, or I decree use 2.4.0, it won't break. There's various ways to work around it. But yeah, mostly, if you have an override though, you cannot be used as someone else's dependency.
The workspace is going away?
Eventually. Don't know how much I should promise here, but
no, but if the workspace is going away, and this is the version, so I mean, if this is the algorithm of choosing something, is it even possible to put more than one version if you use the same database with two major versions on your monorepo?
Yeah, so so the question was, if workspace is going away and this is the only thing that's left, how can we still have multiple versions of something in one workspace? Yeah, there's a thing called multiple version override, which will allow you to do it, yeah. That's basically it. So you can specify multiple version override, and you say both 1.3 and 2.4 are allowed, and whoever requests the 1.3 will see at Bazel Skylib as referring to this one, and that one will see at Bazel Skylib as referring to the other one, the 2.4 one. There's documentation on all this. I consider this advanced topics, to not scare away the newbies. But yeah, there's documentation on the Bazel website about this. Okay, so that was it for dependencies on Bazel modules. For things that are not Bazel modules, such as Maven artifacts and npm packages, Bazel offers module extensions as a solution. So module extensions allow rule authors to define repos beyond just downloading something from the internet and extracting it. So for example, the aspect rules.js module provides an extension called npm that talks to npm to fetch packages, provided that you have a pnpm log file. This will probably only be familiar to people who are used to JavaScript, because I didn't know about this. My days were still from package.json. Apparently that's too old now, or something. But yeah, so if you have a log file, which is stored in a YAML file, you can just say that here. So this is all just copied from aspect rules.js's release page. They literally say, okay, just copy paste this and it'll work. And I tried it, it actually does work. So yeah, so this is how you do it for JavaScript. So this clause, use repo from this extension, this repo, gives you access to this, this repo that has a very arcane canonical name, but just has the apparent name of npm. So this repo is defined by fetching packages named in blah, blah, blah from npm and putting them in the directory. So you would have access to whatever rules.js gives you there.
But Bzlmod also exposes, like if I use Bzlmod, then that is also available for me, right?
Yeah. So Bzlmod also gives you repos. So for example, here you have repos called rules.js or rules.go. Yeah.
So what does use repo then?
Use repo is used with extensions. So you need to say for an extension can generate any number of repos it wants. You basically say which one you want. No worries. So it's worth pointing out that just like how your Bazel depths can have their own Bazel depths in terms of transitive depths, your Bazel depths can also have their like extension usages, and you'll just get that transitively without having to again say like, okay, my dependency wanted something from an npm, I need to fetch that for them. No, like it's all shared in the transitive dependency graph. For another example, you can, if you're more familiar with Java and Maven and stuff, so here you can have rules JVM external, which gives you a module extension for talking to Maven. And it has its own log file format, which is stored in the JSON file. So basically, again, copy paste this snippet. And there's a way to not use the log file with Maven. You just basically here you give it a list of coordinates, Maven coordinates to Maven artifacts, and it'll just talk to Maven and give you the thing. So later we'll. Oh, okay. Hi.
What happens if you have multiple repositories in your dependencies that use the same extension mechanism?
What happens?
Do they like merge the Maven?
Yeah, so the question was what happens if multiple dependencies all use, let's say, Maven, yeah? So Maven, the extension is run only once across the whole dependency graph. And it takes in all the information given to it via these tags.
So it ignores the other ones?
It doesn't. The extension needs to know how to incorporate everything together. So like module, you know, for example, you say you want these coordinates. Let's say rules.go for some reason also wants some Maven artifacts. Then Maven, the extension, will look at all the input from you, from rules.go, and make something.
Is there like a fold or something?
I don't know. Maybe Maven wants to do it a certain way. Maybe it wants to do it a certain. So like you can write your extension to do whatever, but you're given all the information. Yes. Yeah, okay, later we'll briefly touch a bit more on how module extensions actually work and how you can write your own. Okay, so now it's time for some more advanced topics. We don't have time to go into too much detail, but I can give you a general idea of how to take advantage of Bzlmod's extensibility by making your own module, your own registry, your own module extension, your own repo rule, everything. Okay, first up, your own module. So we saw how you can like write your module using the module.bazel file to introduce dependencies and like call extensions. How do you publish your module as a library so others can use it too? And so the first thing you need to do is to build and test your module locally. Then you can do a release as you normally would, make it available on GitHub or somewhere. And then you need to prepare a few things for the registry. So you should already have your module.bazel file, which has basic metadata such as the module name and version and list of the dependencies and extension usages. Beyond that, you need a source.json file, which describes where the source archive is, as in like where did you publish it, on GitHub maybe, as a release archive, not a source download. So where the source archive is, its checksum, any patch files you have, and their checksums. Because Bazel is sometimes an afterthought for a lot of libraries. So like the libraries, they weren't, especially C++ libraries, for example, they were not geared towards Bazel. So sometimes we need to have build file patches, sort of. And the BCR, the central registry, is kind of a home for these patch files. So for the central registry, we also need a pre-submit.yaml file, which describes some basic targets to build and test, so we can run CI and ensure basic interoperability. This is run on Bazel CI. So finally, you can send a PR to github.com/bazelbuild/Bazel central registry. So this URL is the same as bcr.bazel.build. It just redirects here. This is where the central registry is essentially hosted, really. Like the contents are all in the GitHub repo, and it's like served from the bcr.bazel.build URL. So after you send a PR to this, and it's reviewed and merged, and then your module will be ready for use. There are more instructions on this website. So for certain use cases, such as enterprises like Wix, it may be prudent to host their own registry. Whether because you have internal code you don't want to publish, or like just because you want an extra layer of security that you like control immediately. So hosting a Bazel registry is fairly straightforward. You just need a static web server or even a local path, like a local file system that has the same format as the Bazel registry. It's a fairly straightforward thing. It's also like on this page, bazel.build/external/registry, the specification is given to you. Very quickly, it's just like a Bazel registry.json file, which doesn't even need to be there. If you want mirrors, you can specify one there. And a modules directory where each subdirectory is a module, and further in, each subdirectory is a version. And then further in, there's the module.bazel file for it, and the source.json file, which tells you where the archive is actually hosted. And if you want any patches, you can have them in there too.
Do you know if Bazel had any discussions with Artifactory? Like they host many repositories such as these? Also for this?
No, we didn't. The question was, did we talk to Artifactory? No, we didn't.
Maybe it's worthwhile because they have like many different facets. Containers and jars and npm packages and
standard. You can ask Artifactory to look into that.
Yeah, but if I asked it in Bazel, I think it might be.
Yeah, we can talk to them. Thanks. So basically, the promise was that we will talk to Artifactory because apparently Artifactory does a lot of this too. Right. So you can host your own registry just by setting up this format, and then you can specify a list of registries using the -- registry flag, which is repeatable. So like you can specify multiple registries which layer over each other. And if you don't specify any, you just use the central registry, BCR. If you specify any, then we leave out the BCR. So if you want to still use BCR, add -- registry equals bcr.bazel.build at the end. Your own module extensions. So as we touched on before, module extensions allow you to create repos outside of the Bazel module dependency graph. So module extensions, similar to build rules, if you have written any or know about them, they're written in Starlark, which is a restricted subset of Python. So Bazel modules can use extensions, as we see there, and provide information to it in the form of tags, like these, like extension name dot blah stuff. They look like method calls, but they're really just like, they're just static information fed to the extension. So the input to a module extension is all the tags of all the modules that use this extension across the dependency graph. It gets them all at once at the end of module resolution. And then the output of the extension is just a LiPo, a list of repos to generate. The extension is allowed to access the network, local file system, essentially run arbitrary code. So we don't have time to go into details, but like for more information, just go to this link. It has a lot more. And finally, you can write your own repo rule. So repo rule is essentially a template for repo definitions, similar to how a build rule is a template for build targets. It is also written in Stardock. So the most commonly used repo rule by far is HTTP archive, which is the one that backs all the Bzl modules. Download a thing from URL and extract it. One usage can be seen on the right side. So the first snippet, this thing here, is what a module extension, part of what a module extension does. So in the module extension, you basically try to create repos. The way you do it is by calling a repo rule. So you give it a name, you give it a URL, you give it an integrity, which is a hash, like a checksum. So that's so the input to the repo rule is basically these attributes, like name and whatever attributes the rule declares. And the output, or rather outcome of the repo rule is that some files are created in the directory that Bzl prepares for this repo. So similar to module extensions, the repo rule also is allowed to access external resources like internet, file system, whatever. So obviously, HTTP archive needs to download something from somewhere. You can read more about writing your own repo rules at this URL. I don't know how we can share these slides, but I'm sure there's a way, organizers. Okay, where to from here? So there's newly refreshed documentation at Bzl.bazel/external/overview. Touching basically all these topics. You can see some examples. We have examples using Bzlmod at this location. You can browse the registry at registry.bazel.build. This was a web UI contributed by our community. So further contributions also welcome. And come chat with us on the Slack, on the Bzl community Slack. There's a channel for Bzlmod. And that's a wrap.